Good afternoon. Good afternoon. We will now discuss the expression for the solar cell as we have discussed about the solar cell in our last classes, like the VI characteristics of the solar cells, the various parameters based on the solar cells and the types of the solar cells. Here we will drive an expression for the solar cell. Like this is the case we are having the structure, and these are the two terminals of this solar cell. Like we are denoting these two ends by the anode for the anode is denoted by A and K is denoted by cathode, and this is the voltage V that appears across these two ends. Okay, this is the current I that is going through this. So, this is the we are denoting it by the sign that is the photovoltaic cell. We are denoting it over here. This is the diode. These are the different resistances. Like this is anode, this is cathode, this is anode, this is cathode, and this is the voltage V that is connected over here. So this is the current I. This is the resistance RS. This is the resistance RS. This is the current I that is going through this terminal. This is the other resistance that is the shunt resistance that is RSH, and we are denoting the current that is coming from this branches. This is the RSH, this is IRSH. That is the current, this is the shunt current that is coming from this resistance. This is the current that is coming from here, that is we are denoting by IP. Here the current is ID. The current is divided over here, that is the IP current, and the current that is going through this diode that we are going to denote by the ID. Okay, so this is the voltage V, and the voltage across this branch will be IRS. This is the voltage V, and this is the voltage IR, and so the total voltage across this point at this point will be V plus I. This is the current IRS. So how you can write the equation for the IP current? This is the total current that get divided over here. The current that is divided over here, that is this current, and this current. So these are the currents. So how you can write for IP? IP will be equal to divided into ID, IRSH, and divided into this branch. So as per the nodal equation for the current, like how the current division law you can say, आपके पास करंट क्या हो रहा है यहाँ पर डिवाइड हो रहा है, दैट यू कैन राइट एज आई पी इज इक्वल्स टू आई डी प्लस आई आर एस एच प्लस आई. सो फ्रॉम हियर यू कैन राइट द इक्वेशन ऑफ आई. आई आपके पास क्या हो जाएगा? आई हो जाएगा दैट विल बी आई पी माइनस आई डी माइनस आई आर एस एच. ये हमने इधर रखा, बाकी सारी वैल्यूज आपने क्या कर दी, दूसरी साइड लेकर वहां पर आपने क्या कर दिया, माइनस कर दिया. आई इज इक्वल्स टू आई पी माइनस आई डी माइनस आई आर एस एच. सो हाउ यू कैन राइट द वैल्यू ऑफ आई आर एस एच? इस ब्रांच में आपके पास करंट क्या है? आई आर एस एच. दैट विल बी इक्वल टू वी बाई आर. दैट विल वोल्टेज यहाँ पर आपके पास कितना है? वी प्लस आई आर एस divided by R. R is RSH. So it will be IP minus ID minus IRSH. IRSH will be equal to V by R, that is V plus IRS divided by this RSH. So this is the equation of the current. एंड व्हाट अबाउट द इक्वेशन ऑफ द डायोड करंट की हमारे पास जो जनरल इक्वेशन होती है डायोड करंट. तो नेक्स्ट वी विल राइट फॉर द डायोड करंट क्या होता है आपके पास आईडी होता है दैट इज गिवन बाय आई जीरो e raised to power v plus. This is the general equation for the diode current. And Vt, that is the voltage that will be given by the Vt is equals to Kt by Q. आपके पास कांस्टेंट रहता है Q की वैल्यू आप पुट कीजिए एंड डिपेंडिंग अपॉन दैट वैल्यूज बाय पुटिंग दिस कांस्टेंट वैल्यूज व्हाट यू विल गेट इज T डिवाइडेड बाय द 11600. So, if we consider like a value of n is equals to 2, where here this what is this I naught? I naught is the reverse saturation current. I naught is the reverse saturation current that will be given by K T M e raised to power minus VGO by NVT, where K is constant, VGO is the forbidden band gap, forbidden energy band gap. Okay, so here the M will be 1.5, like for silicon. For silicon, its value will be 1.5, and VGO is equals to 1.16 to 1.2 volt for silicon. Now putting these values over here in this equation will become I is equals to IP minus I naught e raised to power from here e raised to power v plus IRS by eta Vt minus 1 e raised to power v plus IRS by eta Ts minus 1 minus the value of IRSH that will be v plus IRS by RSH, v plus IRS by RSH. So this is the value of the current that will flow from this end of the solar cell. Okay. So this is how you can drive the equation of the current that will flow from this end of the solar cell. Like this is the total current that is coming from here that will further get divided through this diode, these two resistances. Then by using the KCL, you have applied this equation and that. So this is about today's lecture.